So hello everyone, welcome back to the channel. I hope you guys are doing amazing. So today I have my batchmate Sohardo Bose from IIT KGP with us, who had bagged an intern at Nvidia. So hey Sohardo, how are you doing?
Yes, I'm doing fine. How are you?
Yeah, I am quite well. And so first of all, congratulations.
Thank you, Mitatru, and congratulations to you as well for securing a placement at Samsung as
Yeah,
an
thank
advanced
you.
developer role. Congratulations, many congratulations to you as well.
So can you explain like how did you prepare for this interview at Nvidia and like what are the topics and stuffs to study and during the summer breaks how did you manage time and stuff like that?
Okay, so okay, so I can first start with the preparation topics.
Yes,
So
yes.
there will be multiple topics when you will be preparing not only for NVIDIA but for any kind of core companies like Qualcomm, TI, NVIDIA, Intel, analog devices, and so many. So
Okay.
so I will be listing the various topics. First, I will be starting with the analog electronics, which is a very crucial topics for any core electronics company interview.
Yes,
So
yes.
there will be multiple subtopics under the analog electronics section, and it is very difficult to list all the subtopics in one slide, but I have tried to list as many as possible.
Okay.
So first, we will be going with the network analysis. Uh, which is a very basic topic which falls under analog electronics. So, under network analysis, the first and the very important part is the first order and the second order RC circuits, which is very commonly asked during interviews. And in this type
Okay.
of questions, you have to give an intuitive explanation of the circuit rather than solving it mathematically by using Laplace transform or the circuit equations. So they will give you a RC network, and there you need, and then they will provide the in the input we are providing a step response, and you have to find out what is the output waveform. So this is a very common question which is asked in TI analog profile interviews, and you have to prepare this kind of questions. And here you have to answer it intuitively without using any kind of equations like KVL, KCL, or something like that.
Okay.
So this covers the network analysis part. Then moving on to the next part, which is the semiconductor devices. So this topic may not be very much asked in NVIDIA interviews, but in other core companies like Intel or Qualcomm, you may get some questions on the semiconductor device portions. So if you prepare this part also, then it will be an added advantage for you. So under
Yes.
semiconductor devices, you can prepare about the basics of quantum mechanics, then how to solve the Schrodinger equations, then the potential well, quantum tunneling. Then you can also read about the PN junction diodes, the metal semiconductor junctions, the Schottky junctions, then how the MOSFETs and the BJTs are characterized. So these are the different subtopics which falls under semiconductor devices, and you can read about them.
Okay.
Then coming to another very important subtopic, which is the MOSFET, and this is also one of the most basic part in under which falls under analog electronics. So it actually starts with the how the two port networks are evolved, and from there only the MOSFET characterization starts. So there you can start with the two port networks, then the IV characteristics of the MOSFETs, then you can read about the current expressions, the different region of operations of the MOSFETs. Then you can also read about the MOS capacitance, which also falls under semiconductor devices. So you can also read about MOS capacitance under semiconductor devices as well. Then another important and very important topic which you can get in the interview questions as well as during your interview before interview the test, online test. So there also you can get many questions from the large signal and the small signal models of the MOSFETs. Then you get questions from early effects, then the short channel effects of the MOSFETs. So these are some of the important aspects which falls under the MOSFET chapter. Then
Yes.
coming to the next topic, we have the BJT, which is also very crucial for analog electronics. So there you can read about the collector base emitter currents. Then you can talk about the IV characteristics, then the different region of operation for the BJT, large signal, small signal model. So BJT and MOSFETs, they are more or less equivalent. So if you read about MOSFETs, then you can easily understand the counterparts for the BJT as well. So both two are almost equivalent and you can read them simultaneously as well. So the next topic which comes under analog electronics is the CMOS and the BJT single stage amplifiers. So the single stage amplifiers are very much commonly asked in any kind of analog interviews, and also you may get questions from this portion in your online test as well, which takes place prior to the interviews. So
Yes.
here you can study about the basics of the common source, the common drain, and the common gate and amplifiers. All are single stage amplifiers, and they will be having either resistive load or the diode connected load or with source degenerations. And you can also read about their BJT counterparts as well. Along with the MOSFETs, you can study the BJT counterparts for the single stage amplifiers as well. So this covers the fifth topic. Then we come across to another subtopic which falls under analog electronics, is the current mirrors. So under this, you can read about the basic current mirror topologies, the biasing techniques, the cascode current mirrors, which and you can also read about the low voltage cascode current mirror. So this will also be helpful in any kind of analog interviews. They may ask you questions from current mirror. So cascode current mirror also in one of my friends TI analog interviews. So the interviewer, he asks question from the cascode current mirrors. So this is also one very crucial and important topic which falls under analog electronics.
Yes.
So the next and the very crucial topic is the differential amplifiers. So you have to read about the basics of the differential amplifiers. Then you have to understand the small signal analysis. Then how the differential amplifiers will behave under the resistive load, under active load devices. Then you can also read about the CMRR and also the other non-idealities in the differential amplifier. So this covers the basics of the differential amplifiers, and there are also many things which you can read if you are curious enough. So you can also read about differential amplifiers also. Then after that, then we come across to op-amp. So op-amp internal circuit design is not very much asked in interviews, neither in the online text. But the op-amp as a black box, there is a chapter in Razavi. You can also read about that chapter. So there you can read about the inverting and the non-inverting configurations for the op-amp. Then how the op-amp behaves under different circumstances, like it can behave like an integrator, it can behave like a differentiator, it can also behave like a voltage adder. So you can also read about all these different behaviors of the op-amp. And then also you can read about the op-amp non-idealities, like the effect of the input offsets and how we can address these non-idealities. So those you can also read about in this particular chapter. Then next topic that we are coming is the cascode amplifier stage. So this is, you may get some questions in the online test from this portion, but interviewers, they may not ask you a significant question from cascode amplifier scheme. So here you can read about the folded cascode, then you can read about the telescopic stage, telescopic op-amp. So these will fall under the cascode amplifiers. So the single stage amplifier that I discussed previously, that you can get questions from the interview. But from cascode amplifiers, you may not get so many questions in the interview, but you may expect one question in the online test. So this is also another important thing. Another very crucial topic which comes under analog electronics is the frequency response and the Miller compensation. So you can read about these topics as well, and this will help you in order to understand the stability response of the circuit and how the circuit varies if you change the how the circuit actually behaves when you change the frequencies. So you have to read about the frequency response and the Miller compensation. And then the next topic which comes is the feedback, which is very important important topic in terms of interview as well as in terms of the online test. So you can ask, you can get questions regarding positive and negative feedback circuits, both at the transistor level as well as in case of op-amp based circuits. Then you can also get questions from different feedback topologies and also the stability criteria, the Bode plots, and there you can get questions from phase margin and the gain margin. Then again, questions from frequency compensation, Miller compensation, and lots many. So this feedback chapter is also a very crucial chapter in order to understand analog electronics, and you have to understand this portion very well. And this will be helpful for your interviews as well as for your online test as well. Then next we will be coming into the basics of oscillators. So here there will be, if you go into this oscillator chapter, there you can find many things, but you can read about the basics of oscillator, which I think will be enough or sufficient for your interviews as well as for your online test. So for oscillator, you can read about the ring oscillators, then you can read about the LC tank oscillators, then cross-coupled oscillators, you can read about them, but this may not be asked so much in interviews on online test, but this will carry an added advantage. If they ask you some question, then you can easily answer the questions from the cross-coupled oscillators. Then the second last topic from analog electronics is the analog filters. This is also very important topics which falls under analog electronics, and you may expect questions both in interview as well as in the test. So analog filters, it covers the first order, the second order analog filters. Then you have the active filters. Then you can also read about the basics of the Butterworth and the Chebyshev filters. So these are the different varieties of analog filters. You can also read about them. And the last topic, which is there under analog electronics, is the comparators. So you can read about the comparator basics, the voltage characteristics of the comparators. Then you can also read about the hysteretic comparator, the clock comparator, and the latch-based comparators. So the last three topics, the hysteretic comparator, the clocked, and the latch-based comparators, they are also not very important in terms of interview or your online test, but you can read about them, because unless and until you read about the hysteretic comparator, the internal hysteresis and the external hysteresis, the comparator will not be complete. So if you have interest, you can read about those hysteretic clock comparators, the latch-based comparators, and there are also other varieties of different comparator schemes. You have dynamic comparators, you have static comparators. You can also go through them as well. So this almost more or less covers the topics which falls under analog electronics and the analog CMOS design. So you can read about these topics. I will come to the references, like from where you can study all these topics later in the later part of the slide. But for the topics, so you can read about all these portions from analog electronics.
Yes.
So yes. So the next topic, which is also very crucial in any interview for digital profile, is the digital electronics. And these will, you can expect questions in NVIDIA, in Intel or TI digital profile. So you can expect many questions from the digital electronics part. So under digital electronics also, I have tried to list down as many subtopics as possible. So this is also a very vast topic in terms of research or in terms of your own interest. So I have tried to list down as many topics as possible. So under digital electronics also, you should try to understand the basics of the MOSFETs. So the IV characteristics, the current expressions, the different regions of the operations of the MOSFETs, and also the MOSCAP, which was also listed under analog electronics also. So MOSFET basics you have to understand in order to understand electronics. So this is a common topic which falls under both. And then the second subtopic under digital electronics is the short channel effects of the MOSFETs. So this is also very important, because as the technology is scaling down, as we are going to lower and lower technology nodes, like we are going to now we are going to 3 nanometer technology as well. So there will be different short channel effects which will be coming in the MOSFETs. So you can also read about different short channel effects, and you can get some questions from here in your interviews or in your online test. test. So under short channel effects, you can read about the channel length modulation, the drain-induced barrier lowering. Then you can also read about the velocity saturation, then punch-through effect, hot electron effect, subthreshold leakage, subthreshold slope, and there are many more short channel effects. You can read about many of them. You can find this in the Razavi book. I will come to the references and the resources later. So this covers the basics of the MOSFETs and also the short channel effects. Then another very, very important topic which comes under digital electronics, which you should go through, and this will you can get questions from in the interview as well as in your online test. So this is CMOS inverter. So you have to go through the detailed study of the transistor level implementation of the CMOS inverters, which includes the voltage transfer characteristics, then the transient response. Then you can talk about the noise margin of the inverter. You can also talk about the delay analysis of the inverter using Elmore delay model. Then also the power dissipation and so on. So similar to the CMOS inverters, you can also talk about all these variants for other logic gates as well, like NAND, NOR, XNOR, and so on. So you can also read about the transistor level implementation of these CMOS inverters and the other logic gates, which will be helpful for your interviews as well as for your online test. Then the fourth subtopic, which comes under digital electronics, is the Boolean algebra, which is also very important. And this is a basic topic which is also covered in class 12 syllabus as well. So you can read about the basics of Boolean algebra and how, and this is another important topic, which is the logic function simplification using K-map. So that also you can read under Boolean algebra. Then the fourth topic under digital electronics is the combinational circuit. So you can read about the adder, the subtractor, multiplier, the magnitude comparator, then decoder, encoder, mux, demux. So there are many which falls under combinational circuits. You can read about them. And then in order to analyze all these circuits, you need to understand the delay analysis using the Elmore delay model, and how you can analyze the delay response for any kind of combinational circuits. You can also read about them. Apart from all these, you can also read about the pseudo MOSFETs. You can read about the skewed and the asymmetric gates. Then you can also read about the basics of the pass transistor logic and also the domino logic. So these will more or less cover the parts or the portions under combinational circuits. Then after combinational circuits, there comes the sequential circuits, the latch and the flip-flops. So you can read about the transistor level implementation of some of the basic latch and the flip-flop topology, which may be helpful for your interview and as well as for your online test. And under sequential circuits, you can also read about the master-slave configuration, and the interviewers may ask you some question on this master-slave configuration for the sequential circuits, which may be helpful for you as well. Then coming to the other part, which is counters. So you can read about the asynchronous and the synchronous up-down counters, and also you can read about the registers as well. So while studying the counters and the register, the state diagrams are very important in realizing them. So you have to, in order to realize the different states of the counters, and also in case of the registers, you have to understand the state diagram. So which is also very important in this portion. Then coming to the next part, you have the frequency divider circuits. You can read about the fractional order division and also the frequency synthesizers, which is also asked in any digital interview. And then the last three portion, you have the memory cells. You can read about the 60 and the 80 SRAM cell, the DRAM cell, and so on. And you can also read about the memory array and how the memory is being addressed. Then also the read-write operations in the entire memory array. You can go through those portions as well. Then another very, very important topic which comes under digital electronics, and this is very frequently asked in interview, and as well as you can get 2-3 questions in your online test as well, which is static timing analysis. So here you can also read about this as well. So in this, I would say ki, you don't have to remember those formulas, but I would say you understand the concepts very well, and you can practice the PYQs in order to ensure better clarity. So this static timing analysis is also very crucial chapter under digital profile. And then the another topic which comes under digital electronics is the criteria and the hazards. So you can also read about the static hazard, the static one, the static zero hazards, and also the dynamic hazards. So these are roughly the crucial and the important topics which comes under digital electronics profile. So you can go through all these topics if you are appearing for the digital profile interview.
Yeah, that's cool. So, would you suggest some sources and like what are the exact interview questions which were asked in to you in the NVIDIA?
In NVIDIA under digital electronics, you can, as I mentioned, short channel effects, you may not get a question in NVIDIA, but you can get questions from in your Intel or Qualcomm interviews. But you may get some questions which may be asked in NVIDIA from CMOS inverters and also other logic gates. Combinational circuits, sequential circuits are very common questions which can be asked in NVIDIA interviews. You can also get questions from counters, registers, frequency dividers. So these are also very important and crucial questions which the interviewers may be interested to ask you in your NVIDIA interviews. And you can also, this memory cells is also memory cells, memory array. You may not get in NVIDIA, but for other core company interviews, you may get questions from this memory cells. Static timing analysis is very important topic which was asked in the online test for NVIDIA as well. And in the interview, the interviewers may ask you some questions from STA as well.
Yes.
So this roughly covers the digital electronics portion. Then coming to the additional topics, which is also very frequently asked in any online test and also the interview. So the first one is the computer programming and the data structures. So any kind of online test for the core companies, you can expect a section related to the computer programming in the online test for the core companies. So this area, Mitadru will be much more proficient in this area rather than me. So you can also read about the basics of programming and the data structures. And in NVIDIA interview, they actually asked me one question from binary tree and binary search tree, which falls under data structures. Then coming to the next additional topic, which is the computer architecture. So you can read about the basics of computer architecture. So you can read about the basics of memory addressing. You can read about the different addressing modes. And also the memory interleaving portion from computer architecture. And then the third point will you can also read about the basics of the RISC and the CISC architecture, the differences between them, and how you can compare the two architectures. Then you can also read about the different bus architecture, the single bus and the multi-bus network, and also how the control signals are there in this two bus architecture. You can read about them. And also you can read about the basics of the memory systems, the cache, the SRAM and the DRAM. And also another very crucial topic which falls under computer architecture is pipelining. You can also read about the basics of pipelining from there as well. And my NVIDIA interview was after my second year. So that time computer architecture was not actually covered in our IIT KGP curriculum. So there are multiple online resources. If you want to study computer architecture, you can also study from there as well. I will come to the resources and the study sources later. Coming to the another topic, which is digital signal processing, which is also very crucial for electronics interview as well as for the online test. And in DSP, you don't have to read about the entire DSP chapter. You can also focus on specific topics. You can read about the Fourier series, the Fourier transform, the Laplace transform, Z transform, and also you can read about the fast Fourier transform, the FFTs, which is also very important for DSP. Coming to the other part, you can also read about the basics of Verilog coding, and also you can read about the basics of probability statistics. You can get a question in the interview as well as in your online test under the analytic section of the online test. You can expect some questions from the PropStat. And the last part is also linear algebra. You can read about the basics of linear algebra for your interview as well as for your online test.
Yes.
Now, yes. So now we are coming to the references and the study sources. So I will briefly go to the different resources from where you can study all these portions. So first, coming to the analog electronics. So there are mainly various books for analog electronics. The fundamental book will be the first one, the Fundamentals of Microelectronics by Razavi. You can also read the Razavi second book, which is the Design of Analog CMOS Integrated Circuits. But this may not be very much helpful for your interview, but if you have interest, you can read about those as well. You can also read the book on by Cedra Smith, the Microelectronic Circuits, which will be very helpful for your interview and for your online test. And you can also watch different NPTEL lectures by Professor Nagendra Krishnapura from IIT Madras. You can go through those lectures as well. They will be really very helpful for you as well. Coming to the digital electronics section, you can read the books by Rabe, the Digital Integrated Circuits, and also Digital Design by Maurice Mano. So these two books are very fundamental and very crucial books for digital electronics. And you can also also watch the NPTEL lecture by Professor Janaki Raman from IIT Madras. And those NPTEL lectures were really very helpful for digital IC design. Then the other resources, if you want to read about the static timing analysis, there will be multiple YouTube videos available online, and also there will be multiple NPTEL lectures. You can refer to any one of them. I have provided one link which I will ask Mitadru to post it in the description. You can also refer to this link. This is very concise and very to the point, and it will be very helpful for your interviews and also for your online test. I think there are only 7 or 8 small videos in one playlist, and you can go through them. The next part is the computer architecture. I actually refer to the NPTEL lecture by Professor Indranil Sengupta from IIT Kharagpur. You can go through that NPTEL lecture for computer architecture. Also for Verilog, you can refer to the NPTEL lecture by Professor Sengupta from IIT Kharagpur. And also for signal and system and the DSP basics, there is also very common and very fundamental book on signals and systems by Oppenheim. And also you can refer to DSP by Proakis. You can refer to these two books if you want to go and study the basics of the digital signal processing. Then coming to the another topic, which is semiconductor devices, there is also very common book which is by Streetman and Banerjee, the solid state devices. I think the book name is Solid State Electronic Devices by Streetman and Banerjee. You can read about semiconductor devices from that book as well. And then you can read about frequency synthesizers. So this is the third book of Razavi, the RF Microelectronics by Razavi. You can go and read about frequency synthesizers from this particular book.
Okay, so that was a lot of insights about the references and study sources. So can you tell me about the exact questions which were asked in the NVIDIA interview, and how did you handle those?
Yes, actually I'm trying to recollect the questions that were asked from my interview at NVIDIA, and the interview actually happened in I think August 2023. So I actually forgot many of the exact questions, but I'm trying to list them as much as I could recollect.
Yeah, as much as you can remember, that's fine.
Okay, so the first question, which is asked in every interview, first you have to introduce yourself.
Yeah.
Then the interviewer surprisingly asked me one question on what are the subjects that you have taken in your current semester. So for me, it was my 5th semester. So there I actually took, I think there I took power electronics, digital signal processing. I think control was also there. And there were also a lot other subjects as well, which was there in my current semester. I actually answered them.
Yeah.
And then he actually asked significant questions from my resume as well. So, so the first question, so I actually had done 2 projects and I actually listed them in my resume. The first was the 7-bit counter design, which I have implemented at the transistor level. And it actually consisted of 4 to 5 stages. The first one was a very high gain cascode op-amp. And then the second stage was a V2I converter, then followed by a current starved current controlled oscillators. Then you have the registers and the counters in order to count the bits for the counter. So he was actually very interested in this counter design project, and he actually asked me a couple of questions from here as well. So he actually asked me first in order to explain the design aspects of the 7-bit counter. So I actually briefly explained what was the design stages that were involved in the 7-bit counter, and also how I am getting the 7-bit resolution. I explained the interview interviewer. And then after that, when in the op-amp design, I actually in my resume I mentioned the design category step by step. So there I actually mentioned about the capacitive feedback which was involved in the design of the cascoded op-amp. So he was actually interested, and he actually asked me, why did you use capacitive feedback instead of very commonly used resistive feedback? So this is also very interesting thing. So here, since the op-amp needs to be a very high gain, so and why a high gain op-amp is required? This is because the input signal that will be coming to the op-amp will be the peak to peak of that input signal will be very low, in orders of maybe hundreds of microvolts. So first we need to convert that input low voltage signal to a substantial peak-to-peak signal swing in order to ensure it to be in the proper operating range. So that is the reason we need a very high gain cascoded op-amp. And in order to ensure a very high gain, we have actually used a cascoded topology for the op-amp. So, and then coming to the question, why capacitive feedback is actually used in this op-amp design. So in order to ensure a very high output impedance of the op-amp, which is very important for the high gain of the op-amp, if we use a resistive feedback, then the op-amp gain was getting limited because of the feedback resistor. So that is why we actually used a capacitive feedback in order to ensure the high gain stage of the op-amp. Coming to the another part, he also asked me about the design characteristics of the current controlled oscillator. So there I actually talked about the current start configuration for the current controlled oscillators. And also I also explained him why the current start configuration was helpful, which was actually his second question, the next question. So I actually explained him why the current start configuration is very helpful in any kind of oscillator topology. So this current start configuration helps in order to achieve a wider frequency control, and also helps in precise tuning. So this is the very important reason why we have also implemented the current start topology in our counter project. So this is also a very interesting project that the interviewer also found it interesting, and he asked me a couple of questions from this particular project. Then coming to his next question was, since I actually worked on op-amp in my that counter project, so he actually asked me a question on an op-amp. So he told me that you are actually provided with an op-amp IC which is having a very high gain, and your VDD and the ground, the supply signals are provided, some value he actually specified in the question, and he actually provided an input sinusoidal voltage having a peak to peak value which was also specified, and he actually asked me what will be the output voltage swing for this op-amp. So then, so here you can understand that it's a very common question. So you can just have, you have the input signal, you have the op-amp gain, you have to just consider the non-idealities if specified in the question, and you have to calculate the final voltage output swing. But here the main tricky part was here, that is that you have to consider the edge case where the upper PMOS transistors for the op-amp may be going into cutoff, and the output will be clipped to the supply. So the output may get clipped to either VDD or either ground. So you have to consider that portion as well. So this is one tricky part that was there in this particular op-amp question. Then the fifth question that he asked was on my second project, which also I did in my undergraduate course. So the second project that I did was on radiation tolerant LVDS transceivers for SerDes ICs. So if I just give you a brief idea of what is a LVDS transceiver. So LVDS stands for low voltage differential signaling, and this type of LVDS transceivers are very much used for very low power data transmission for inter-chip communication. So he was also very much interested about this particular project, and he asked me a couple of questions from here as well. So the first question that he asked from here was, in order to just general question, they talk about your project and the work that you actually contributed to it. I actually explained him about the LVDS transceiver topology and what work I actually involved here. So, actually, just to give a brief overview, this SerDes IC, it was actually a group project. So I, along with many of my other friends, were actually involved in this particular project, and we were collaboratively working together. So my part was on handling the LVDS transceivers. My other friends were there. They were also working on, some were working on quadrature VCO, some were working on serializers, deserializers, some were working on this flip-flop based schemes, and so on. So there were multiple segments. So we were actually collaboratively working together in order to design the entire Certis module. So I explained him about my work and also the other works briefly. Then after that, the second question that he asked me was about the importance of radiation hardening, and also what are the techniques that you have utilized in order to mitigate the effects of radiation strikes. So I talked about the radiation hardening importance. So why radiation hardening is very important? Because first of all, just to give an idea, is that this LVDS transceiver project was actually an ISRO sponsored project. So for in a very high radiation environments, when there is a significant amount of radiation strikes in the outer space, then the transistors show very crucial anomalies in their behaviors. So you can find significant amount of charge and spurious currents in the transistor's internal behavior. And in order to mitigate those undesirable behaviors, we have to implement these radiation hardening topologies. So he actually asked me, what are the techniques that you actually used in order to mitigate the effects of radiation strikes? So I actually talked about active node splitting, majority voting, and also we actually used another particular scheme, which is DCC, which is also a layout based scheme. So you can also read about all these different radiation hardening schemes if you are interested here. And then the third question that he actually asked me, what was actually the usefulness of the LVDS transceivers, which is of course a very common question. So it was actually used for very low power on chip or the inter-chip data communication. And he also asked me one of the very another question I was also very surprised to hear. He actually asked me, how will the ISRO team use your IC? So there actually I was wondering like why he actually asked me this question, but there I actually answered like they may be so since it's a radiation tolerant IC, so it will be the radiation strikes will be completely mitigated, and you will not have any kind of radiation effects in the final output. And you can use this IC for very high speed data communication at very low power consumption, since and we are actually operating this IC, I think for 1 gigahertz frequency range, which is very for a very high frequency, and at the same time it was radiation tolerant. So in this way, so there were two benefits of this particular project. So he was also
That
very
sounds
interested in this.
interesting.
Yeah, so actually he was also very much interested in this particular project, and he also asked me a couple of questions from this. So I actually listed mainly these two projects. One was the 7-bit counter and the second one was the LVDS part. So these two projects I actually mainly listed in my resume, and he actually surprisingly he actually asked questions from both the projects. So the other part that he also asked questions from was he actually also asked questions from computer architecture. Like he actually provided me a Google Doc link, which actually consisted of a list of I think 15 to 20 computer architecture questions. The questions were like true and false type. So he actually asked me to answer as much as possible. So initially I actually at first told him and admitted that computer architecture was not yet covered in my IIT KGP curriculum
Yes.
at that time.
Yes,
But yes, so there, but I tried to answer as many as possible because I just went through the basics of computer architecture from Professor Indranil Sengupta's lecture. So I tried to answer as many as possible. I don't have the question list right now, but there were some questions from computer architecture as well. And I can name some of the topics that were from where the question was asked. The topics where I think there were some questions from pipelining. There were significant number of questions from memory addressing and also the bus architectures. So I actually highlighted those topics under computer architecture portions. You can read about those particular topics as well.
yes.
The other question that he actually asked me was a question involving flip-flops and the counters, a sequential circuit-based question. And this type of a similar question actually appeared in our online test, which actually happened prior to my interview. So he asked one such question from flip-flops and counters. So I was able to answer and explain by drawing the state diagrams. I was able to answer that particular question. Another question that he asked me was actually a difference between a binary tree and a binary search tree, but I was actually not very well familiar with that. So I actually answered that I will read about about this particular thing, but actually I was not very much well versed. He actually told me to describe this using some drawing diagrams or something similar. So I actually was not very much familiar. So I actually told him that I am not very much proficient enough in data structures, but I will obviously go through and read about them. So this is also one key thing in which is very important in any kind of interview, is that you have to be honest. If you don't know any answer to a particular question, you should say ki, no, I don't know the answer currently, but I will read about them later. So instead of wasting time and saying something which does not make any sense, so you should admit, and they actually test your honesty as well in your interview.
Yes, yes.
And yeah. So, and the another question that he actually asked me was a programming question. So it was actually finding the longest possible subsequent substring. So there actually they did not focus on any syntax or any programming language. They actually their main target was to focus on how you're thinking, your approach of thought. So that is very important in any kind of programming question that is asked in any interviews, whether in core profile or even in the non-core profile. So the another question, I think this was probably the last question that he actually asked me, was on a probability question, which is a very common
Yes.
question. Like I think there was a bag consisting of blue balls, red balls. You have to pick some certain balls. You can pick only one at a time or something like that. So one probability question that he actually asked me, and I was able to answer that question. So I
Yes, yes.
think, yeah, this was the last question that he asked me, and then after that the interview actually concluded, and the total interview time was, for me, it was around 50 minutes. So the 50 minutes overall duration it was.
Yeah, that sounds cool. So yeah. And so do you think that CV was also important in your selection process? And like what advice would you give to the juniors for to stand out to the recruiters for by like how will they make their CV impressive?
Yes, truly speaking, for me, CV was very important because like he actually asked me a couple of questions, not a couple of questions, many questions from my CV actually.
Yes, yes.
So actually the main thing is that if you have any project which is very much relevant to your profile, or which the interviewer also finds it very interesting, then he or she may ask you question from that particular project which you highlighted in your CV. So the main thing that I would like to say is that anything that you specify in your CV, you should be very well versed in that. Because if he asks you any question from your CV, you should be able to answer that immediately. So yes, CV is an important aspect in my interview. But I have also seen many of my friends interview, like they also shared their experiences to me. So if you, especially in core interviews, even if you don't have a very relevant project in your CV, that is also sufficient. So in that case, they will ask you questions from the topics which I mentioned previously. So for any core interview, apart from the CV, yes, CV is important, and they may ask you questions if they find something interesting. But apart from that, your basics and your basic understanding of the topic should be very clear. Because not for NVIDIA, but for TI interview, they even don't look at your CV as well. They don't ask you questions much on your CV. If they find something interesting, they may ask you, but mostly they don't ask questions from your CV. But they actually focus on your basic understanding of your concepts. So yes, CV is important, but even if you don't have anything much significant in your CV, that is also not a very issue if you are very well proficient in your in the topics that you have covered, that you have learned.
Okay, okay. So can you go ahead with some extra suggestions or something uh, regarding the
Yeah.
interview?
So yes, so like suggestion wise, I can give certain strategies for your interview as well as for your online test. So the first one, as I mentioned already, so you have to focus on your absolute basics, which is very much important for any core company interviews. Like
Yes, yes.
if you just see a topic which is very commonly asked in TI interviews is RC circuit, which is a very basic topic. And you have also covered these topics in your class 12 syllabus as well. But they actually want you to intuitively understand the circuit, whether you are being able to comprehend the circuit by your intuition rather than by using big mathematical equations. So you have to mainly focus on your absolute basics, which is very important in any kind of core company interviews.
Yes.
And same thing, understand the concepts extremely well, which is very helpful in any interview as well as for your online test. And you can also try to solve previous year questions from various topics, which was also very helpful in NVIDIA, because in the NVIDIA online test, there are also some questions from the PYQs, similar questions from the PYQs. So if you solve the PYQs, not only for NVIDIA, for any core company interviews, you may get some benefit. You can get a pattern of what type of questions are being asked, or in what topics the questions are actually asked. So you can also go and solve the previous year questions as well. And the funny part for core company interview is that you don't require any kind of last minute preparation. If you go by the topics, if you just understand it pretty well, you don't have to prepare anything at the last minute. So you have it actually, the topics gets inbuilt in you, and you don't have to prepare anything at the last moment. So this is very funny and interesting part for any core interview. The last another thing that I also mentioned also, key, if you don't know anything, you should be very honest and admit it during the interview, which also happened to me when he actually asked me the question on the data structure, which I was not very proficient enough, and actually I admitted it and I was honest during the interview. And another suggestion that would be, if possible, you can also get involved in your in any kind of projects under the supervision of professors, or you can also do any kind of suitable self project, which you can provide in your CV. And if the interviewer find it very interesting, he may ask you some questions from your CV as well, because the projects that you mention in your CV, that is that actually test that you are actually really interested in that particular field, and you are actually focused in that particular area of interest. So if you have any relevant project in your CV, that carries an added advantage, and the interviewers may ask you questions from that if he or she is interested in that particular project. And last but not the least, I should say, is that for all of you, enjoy what you're doing, and you let only your interests define your career path. So you should focus on your interest. You should be passionate enough and follow your interest. If you are interested in any core profile or non-core profile, you should be very enthusiastic in that particular area, and you go and pursue your career in that particular domain.
Yeah, so
I think that's
guys, let me tell you something about Sohardo. Like, he is one of those rarest guy who got a chance at NVIDIA, but he did not go. Instead, he went to Purdue University for an internship, and he is going there for integrated PhD degree also. So, like, what is your interest area? Like, what will you be working on, focusing on primarily at Purdue University?
Okay, in my PhD, I will be mainly working on spiking neural networks and neuromorphic computing. So I will be working on both the algorithm as well as the hardware aspects. So I will be looking into the hardware and the algorithm co-design for the efficient neuromorphic computing. So if I want to give you a brief understanding for what is a neuromorphic computing all about. So neuromorphic computing, also referred to as brain inspired computing. So in present scenario, there is requirement of a huge amount of computations which require huge amount of power consumption. So this brain inspired computing tries to mimic the computational capabilities of the brain and tries to implement or map it on the hardware. So so that will actually save a lot of your power budget. So actually there is a recent study which was done, you can find many a fruit fly which can actually hover around many places. It can dodge certain obstacles and fly around, and it has been found that it actually takes only microwatts of power consumptions for a fruit fly. But a similar fruit fruit fly was actually implemented on hardware under CNN topology. So there it was found that it actually takes around, I think, 1 or 2 watts of power consumption. So in that case, you can actually compare the difference between the biological brain and also the difference between the CNN architectures that are available. So we are actually trying to reduce the power consumption by mimicking the effects, by mimicking the computational capabilities of our brain on the hardware. So that will involve both hardware level innovation as well as on the algorithm side innovations as well. So this will
Yeah.
roughly the larger field that I will be working on in my PhD at Purdue.
Yeah. So that sounds really interesting stuff. So yeah, I think this
So
would be all.
that's all.
Yeah.
Hmm. So that's all from my side. Thank you all, and best of luck to everyone for your upcoming interviews, online tests, and anything. Thank you.
Yeah. So thank you so much, Sohardo. Wish you all the best.
Thank you. Thank you. Wish you all the best too. Have a nice day.
Yes.